Okay, so in the last video I explained what stress and strain were, hopefully, and in this video I want to talk about the relationship between the two. So I'm going to use this bar to help me. So let's say we have a bar and we know its area and we have its length, and let's just say it's stuck, so it can't move. It's a static problem. So let's say a force is applied to it, a tensile force is applied to this bar. So we know it's going to stretch by some distance x. But what I want to explain in this video is how those two are related, how the force is related to that change. So I'm going to use a graph, as you do. So force over the extension in the x-axis. So we've got force is increasing, and as force increases, this extension increases. But how? So first of all, as you start to pull on the bar, the relationship is actually linear. The force is proportional to the extension, and that's what's known as Hooke's law. So that's going to happen up until a certain stress and strain is reached, up until a certain force is applied to this bar, and it's going to reach what's known as the limit of proportionality. So that's where this relationship stops being so nice and straight, and then it starts to deform a little bit, and then fully deform, and it starts to you can imagine if you pull on a piece of metal hard enough, it'll eventually reach a point where it'll start to stretch. It's like a spring. If you pull a spring, if you pull a spring, it's going to eventually reach that point where it's not going to return to its original shape. It's going to stretch and be fully deformed. And so we call this point the limit, spell this right, of proportionality. And up until this point, this next point, this is what's known as the limit of elasticity. I'll explain that in a second. Elasticity. Okay, now what that means, basically, up until that point, if you were to let go of that force, the extension would decrease and it would return back to its original length. If you imagine pulling a spring, and you can sort of feel when it's about to start sort of bending, well, if you let go of that spring, it's going to return to its original length, and that's what would happen with a bar of metal. So up until that point, this is known as the elastic range, and after that, it becomes this is the plastic range. Plasticity, it means it's deforming permanently. Its length will be forever changed, basically, after that. After this point, after that force has become greater than that. Okay? So, like I said, this is the limit of proportionality, and up until this point, Hooke's law applies, which just says that the force applied to a material is proportional to the extension up until the limit of proportionality, and then there's this tiny area where it's still elastic but not linear. Okay, so force is proportional to the extension. Now what this means is also, since we know stress is force over area, and strain is just this extension over L, well, these two are constants. Area is not really going to change much, it's negligible, and L isn't going to change either, it's constant. So what we can say is that the stress is proportional to the force, and so the strain is proportional to X, and therefore the stress is proportional to the strain. Okay, so you can also put that as the stress, that looks more like a 6, but the stress is equal to some constant multiplied by the strain. Now this constant is something very important. It's known as the Young's modulus of elasticity. And it has the symbol E. So let's just do some rearranging. So you can say stress is equal to Young's modulus times the strain. So you can say the Young's modulus is equal to the stress divided by the strain, which is pascals, because that's pascals divided by a dimensionless unit leaves you with Pascal. And this is a very important value when you're dealing with materials, because if you know Young's modulus and you can work out the stress, then you can work out the strain it's going to be caused. You can work out how much a material is going to stretch by, which is obviously very important when you're designing huge structures that are going to encounter large forces. You need to know how much something's going to bend, and this is also used in figuring out beam bending and when failure is going to happen, which I'll explain in another video. So I hope that made sense.